Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel, Karna Academy. Dear student, in this video, we are going to discuss some of the extra important questions from the chapter of coordinates in space. From question number 1 to 9, already we have discussed in the previous videos. So if you have not watched, please watch it. And in this video, we are going to solve some of the problems which is related to the application of the distance formula. Dear students, by using the distance formula, we can find the equation of a sphere, because we know that the center of the sphere, because we know that all the points lying on the sphere are at equal distance from the center of the sphere. So if the center is given and the radius of a sphere is given, then we can easily find out the equation of a sphere by using the formula of distance between any 2 points. So let's solve the question which is related to the equation of a sphere. So dear student, the question is, find the equation of the sphere whose center is 1, minus 2, 3 and radius is equal to 4. So dear student, in order to find the equation of a sphere, we are given the center and the radius of a sphere. And by using it, we are going to find out the equation of a sphere by using the distance formula. So this is one of the application of the distance formula. By using distance formula, we can find out the equation of a sphere. So dear student, let us represent this question by making a rough diagram. So dear student, let's make a sphere. Let's make a sphere whose center is given as 1, minus 2, 3 and radius is 4. So this we know that a sphere is a three-dimensional solid object. So any point on this sphere we can suppose as x, y, z. We can represent the coordinates of any point on the surface of this sphere as x, y, z. So let's make a diagram. So dear student, the center of a sphere is given. So let's write down the center of a sphere. Let's represent the center of the sphere by the letter C. The center of a sphere, the coordinates of the center of a sphere is given as 1, minus 2, 3. This is the center of the sphere. Dear student, now the radius of the sphere is also given, which is 4 units. The radius, that means the distance between center and any point of the sphere, is called the radius of a sphere. So dear student, the radius of the sphere is given 4 units. 4 units. Let's suppose any point on the surface of the sphere as A, then CA, or we can say AC will be the radius of the sphere. So dear student, by taking the center of the sphere 1, minus 2, 3 and taking the radius equals to 4, we have find out the equation of a sphere. So let's suppose any point on the sphere. Dear student, in order to find the equation of a sphere, let us represent all the points of a sphere by px, y, z. Let's suppose px, y, z be any point on the surface of a sphere. So dear student, now we'll use the distance formula. We'll suppose the coordinates of the center as x1 comma y1 comma z1. The coordinates of the center, let us suppose as x1 comma y1 comma z1, and any point on the sphere which we have supposed as px comma y comma z, let us suppose as x2 comma y2 comma z2, so that it will be easy to apply the distance formula. Now let us use distance formula. The distance between C and P we can take as 4 units, because the distance between any point on the sphere and the center, the distance between center and any point on the sphere is radius. So CP we can take equals to 4 units. Now let's apply the distance formula. Let us use distance by taking the center as the first point and the point P as the second point. So we know that the distance between 2 points in the space, or we can say in the case of 3-dimensional solid object, in the case of 3 dimension, the distance between any 2 points in the space is given by the formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So let's write it down. Equals to 4 units. Let's do SBS, squaring on both sides, so that root will cancel. So dear student, let us substitute the values of the corresponding values of x1 y1 z1 and x2 y2 z2. After that we'll be squaring on both sides. X2 minus x1, the value of x2 minus x1. X2 minus x1 means x2 means x and x1 means 1. So x2 minus x1 means x minus 1, then whole square, plus y2 minus y1 whole square. Y2 minus y1 means y minus minus plus 2, plus z2 minus z1. Z2 minus z1 means z minus 3 whole square equals to 4. So dear students, simply we have put the value of x1 y1 z1 and x2 y2 z2 in the distance formula. Now let's do a squaring on both sides, so that root will cancel, and by after simple calculation we will get the equation of sphere. So when we do a square on both sides, root will cancel. So root will cancel from the left side if we do a square on both sides, and on the right hand side there will be 4 whole square. So let's do the calculation. Dear students, let's expand x minus 1 whole square by using the formula of a minus b whole square. We know that a minus b whole square is equal to a square minus 2ab plus b square. Dear student, x minus 1 whole square means x square minus 2x plus 1. Dear student, x minus 1 whole square means x square minus 2x plus 1 and y plus 2 whole square, which is in the form of a plus b whole square. We know a plus b whole square is equal to a square plus 2ab plus b square. So let's expand by using the formula of a plus b whole square. A square means y square plus 2ab means 2 to the 4y plus b square means 2a square, which is equal to 4 plus z minus 3 whole square, which is in the form of a minus b whole square. And we know that a minus b whole square is equal to a square minus 2ab plus b square. So let's expand it. So dear student, so by expanding z minus 3 whole square, we have got z square minus 6z plus 9 and 4 whole square means 16. So we are almost at the end of this solution. So let's do simplification. So first writing the terms with highest power, that means x square plus y square plus z square, because we have to write down the equation in the general form. Then we write down the term containing power 1, that means degree 1, 2x plus 4y minus 6z. At last we write down the constant term 1 plus 4 5, 5 plus 9 14. And if we move 16 to left hand side, then it will be minus 16. Dear student, x square plus y square plus z square minus 2x plus 4y minus 6z and minus 16 plus 14 means minus 2 equals to 0. So dear student, x square plus y square plus z square minus 2x plus 4y minus 6z minus 2 is equal to 0, which is the required equation of the sphere under the given condition. So dear student, let's review once the solution of this problem, this question. So in this question, we are given the center of a sphere and the radius. So by using the center and the radius of a sphere, we have find out the equation of a sphere. So at first, we have taken any point on the sphere as p, x, comma, y, comma, z, and then the distance between center and any point on the sphere is radius. So by using the distance formula, Cp is equal to 4, it is the radius. Then by using the distance formula and after simple calculation, we have got the required equation of a sphere. Now next, let us move to the next question, which is also related to the equation of a sphere. So let's go to the next question now. Dear student, the next question is, so that the center of the sphere which passes through the point 0, 0, a, 0, 0, 0, b, 0, 0, 0, c is a divided by 2, b divided by 2, c divided by 2. Dear student, here in this question, we are given 4 different points of a sphere which lies on the sphere, and by using the given 4 points of the sphere, we have to show that the center of the sphere is a by 2, b by 2, comma, c by 2. So the question is very simple. So at first, let us represent this question by means of a rough sketch, by a rough diagram. So let's make a rough diagram at first. Dear student, a sphere is given, so we have drawn a rough diagram of a sphere, and we have to find out the center of this sphere. We have to show that the center of this sphere is a by 2, b by 2, comma c by 2. For to find the center of this sphere, we are given 4 points. The 4 points are 0, comma 0. Let's suppose the first point is a 0, comma 0. Second point is a, comma 0, comma 0. The second point is given as b, a, comma 0, comma 0. Dear student, this is the rough sketch. So simply we are going to show 4 given points on the surface of the sphere. The third point is C. Let's denote it by C. The third point is 0, comma b, comma 0. And let us denote the last point, the fourth point, by the capital letter D, 0, comma 0, comma C. So dear student, by using these 4 given points of the sphere, we have to show that the center of a sphere is a by 2, b by 2, and c by 2. So dear student, let's join the center of the sphere. Let's join all the points with the center of the sphere. Let's suppose that the center of a sphere is p, x, comma y, comma z. Dear student, now to find the coordinates of the center, to show that the center of this sphere is a by 2, comma b by 2, comma c by 2, we have supposed that the coordinates of the center, we have supposed that it is p, x, comma y, comma z. Now we are going to find out x, y, and z. That means x, y, z coordinates of the center of the sphere. Now in order to find the center of the sphere, we are going to use distance formula, because we know that all the points lying on the sphere are at equal distance from the center of the sphere. So we'll find out the distance between AP, BP, CP, and DP, and all the distances will take equal, and then by solving the 4 equations, by equating AP with BP, again equating AP with CP, equating AP with DP, we'll get the value of x, y, and z. That means we'll get x, y, z coordinates of the center of the sphere. So let's solve it. So dear student, at first we are going to take AP equals to BP. So taking AP equals BP, and let's apply the distance formula. We know that the distance between any 2 points is given by the formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So dear student, so we are going to find the distance between A and P. So let's apply the formula x2 minus x1 whole square. That means we get x minus 0 whole square plus y2 minus y1 whole square. That means y minus 0 will get y minus 0 whole square plus z minus 0 whole square equals to, now BP square. Let's find out the distance of BP by using the distance formula. X2 minus x1, that means x minus a plus Again, let's use the distance formula. X2 minus x1 means x minus a whole square plus y2 minus y means y minus 0 whole square plus z minus 0 whole square. So x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So dear student, by taking the distance of AP and BP, we have done a squaring on both sides so that root will cancel. Now x minus y minus 0 whole square, the last two terms y minus 0 whole square, z minus 0 whole square are same on both sides, so we can cancel. Now x minus 0 means x, so it is x square. X minus a whole square means x square minus 2ax plus a square. Again, x square are same, so we can cancel. Minus 2ax moving to left hand side. Again, a cancel. So the value of x will be a divided by 2. The value of x is a divided by 2. So which is the x coordinate of the center of the sphere. Similarly, let us find out the y coordinate, which should be b by 2. Dear student, let's follow the same process. So dear student, the x coordinate of the center of the sphere under the given condition we have found x equals a by 2. The x coordinate is a by 2. Now to find y coordinate of the center of the sphere, we are going to equate AP with CP. Already AP and BP, by equating AP with BP, we have got the x coordinate. Now equating AP and CP, we'll get the value of y coordinate of the center of the sphere. So let's write down AP equals to CP. Because AP and CP are the radius of the sphere, and the radius of the sphere are always equal. AP square is CP square. Let's do squaring on both sides. So distance of AP, already we have found x minus 0 whole square, y minus 0 whole square plus z minus 0 whole square. So dear student, x minus 0 whole square, x minus 0, y minus 0 whole square, z minus 0 whole square. That means we'll get x square plus y square plus z square. Now CP square. The distance between CP will be x2 minus x1 means x minus 0 square. That means we'll get x square. Y2 minus y1, that means y minus b whole square plus z2 minus z1, that means z minus 0 whole square. So dear students, simply we have to use the formula of distance between any two given points. The distance formula is d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now x square we can cancel, and z minus 0 means we get z square and z square cancel. The remaining terms are y square, and a minus b whole square means a square minus 2ab plus b square. So again y square same cancelling from both sides. Minus 2by moving to the left hand side, then it will be plus bb, they are same. Therefore y is equal to b divided by 2. So dear student, this is the y coordinate of the center of the sphere, which is same as our question. Dear student, at last we are going to find out the z coordinate of the center of the sphere. Dear student, the z coordinate of the sphere will find again by using the distance formula and equating AP and DP. So we'll equate the distance of AP with DP because both are the radii of the same sphere. So let's write on AP is equal to DP. So taking AP, distance between AP and distance between DP. So AP is equal to DP. By squaring on both sides, we'll get AP is equal to DP. We'll get AP square is equal to DP square. So dear students, distance of AP already we have found, which is x square plus y square plus z square. And distance between DP means x2 minus x1 whole square. That means x minus 0 whole square. We get x square plus y minus 0 whole square. We get y square plus z minus c whole square. Will get z minus c whole square. X square and y square, both sides they are same, so we can cancel. Then we get z square equals to z minus c whole square. So dear student, now z square and z square both are same, again cancel. Minus 2zc moving to left hand side, it will be plus cc cancel, 1c will be remaining. Therefore z is equal to c divided by 2. Dear student, hence px comma y comma z, we have found x coordinate, y coordinate and z coordinate of the center of the sphere. So let's write down conclusion. Px, y, z, the value of x we have got a by 2, y b by 2 and z c by 2. A by 2 comma b by 2 comma c by 2, which is the center of the sphere under the given condition. Hence it is proved. So dear student, once let us review the solution of this question for better understanding. So dear student, in this question we are given 4 points 0 comma 0 comma 0, a comma 0 comma 0, 0 comma b comma 0, 0 comma 0 comma c. We are given 4 different points of the sphere and we have to show that the center of the sphere is equal to a by 2 comma b by 2 comma c by 2. So dear student, this is simply the application of the formula of distance between any 2 points in the space. So simply we have used the distance formula and then we have got, by simple calculation we have got the center of the sphere. First we have supposed the center of the sphere as px comma y comma z and the given 4 points we have supposed as a b c d. Then we have found the distance, we have found the distance of AP and BP. Then by equating AP and BP, we have got the x coordinate. Equating the distance between AP and CP, we have got the y coordinate. Similarly, equating the distance AP with PD, or we can say GP, we have got the z coordinate. X, y and z coordinate of the center of the sphere, we have got a by 2, b by 2, c by 2, which is proved. So dear student, I hope that you have understood the solution of this question. Thanks for watching this video. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.